All right, definition for minimizing average cost. So if the average cost can be minimized, sorry, I'm missing minimize, it will be a production level at which the marginal cost has to be exactly the same as the average cost. Okay, so this is marginal cost and this is average cost. All right, example 6a. Suppose c of x equals x to the third minus 20x squared plus 20,000x is the cost of manufacturing x items. Find a production level, which is x, that will minimize the average cost of making x items. So the formula for minimizing average cost, students, is the average cost has to equal to the derivative of the cost function. So from here, let's find the derivative of the function. Okay, so c prime of x equals, this should give us 3x squared minus 40x plus 20,000. Okay, now we have to also find the average cost, which means we are going to take the function and then divide it by x. Well, your function is x to the third minus 20x squared plus 20,000 x, and then we're just going to reduce the x. So now we have x squared minus 20x plus 20,000. These two equations, we are now going to set them equal to each other and then try to solve for x. So 3x squared minus 40x plus 20,000 equals to your average cost equation, which is x squared minus 20x plus 20,000. As you can see here, the 20,000s will cancel each other out. So I'm going to move it over and then see if we can factor. So subtract x squared over, so we are going to end up with 2x squared. Add 20x, and now I'm just going to have 20x left, equal to 0. Looks like I can factor out a common factor of 2x. If that's the case, I have x minus 10 left. Take each factor and set equal to 0. So 2x equals to 0. X minus 10 equals to 0, so I'm going to end up with 0 here, and then over here I have 10. For this particular context, it does not make sense, right, to produce 0 items. So to minimize average cost, students, this company would need to produce 10 items, okay? So to minimize average cost, 10 items would need to be made. Box that up. All right, let's go and try example B. Suppose the cost function is now x to the third minus 6x squared plus 15x, where x is now representing thousands of units. Is there a production level that minimizes average cost? If so, what is it? Okay, guys, so we want to take the marginal cost and set it equal to the average cost. So c prime of x is 3x squared minus 12x plus 15. Average cost, students, is we're going to take the original function, x to the third minus 6x squared plus 15x and divide by x. That will reduce down to x squared minus 6x plus 15. Take these two and set them equal to each other. So that's 3x squared minus 12x plus 15 equals x squared minus 6x plus 15. The 15 will cancel. Move the x squared over, so we have 2x squared. Add 6x's to both sides. That's 6x equals to 0. Take out 2x, so that's your greatest common factor. You should have an x minus 3 left. Take each factor, set it equals to 0. x equal to 0. Well, it doesn't make sense to make 0 products in this application. So the other answer is going to be 3. But remember, it's 3,000 units. So make sure we add in the thousands. So students, now we have a minimized cost here. So to minimize average cost, okay, 3,000 units needed to be produced. Box that up.